A Merry Christmas to all of you. My name is Dushyant and I'm going to talk about features of an ideal IaC language. Um, First of all, let's quickly chat about Festive Tech Calendar. So this video is part of the Festive Tech Calendar 2021 and the link to the calendar is down here. Definitely visit it. There are lots of fun videos, lots of informative videos and blog posts and many other live telecasts as well. So hopefully you enjoy it. Now moving on with our topic, what is IaC? So IaC is infrastructure as code. So it's codifying how we manage the configuration of cloud infrastructure or maybe virtualized local infrastructure as well. I say virtualized because it's generally easier to codify or write in code the configuration for virtualized infrastructure. In this example, if you see, we have a person, a user or a developer who writes code, and in this case, infrastructure as code, and that code we can version control, we can put it in a Git repository, and we can pull to the same code to our automation server, and that can manage, in this case, deploy, destroy, or change the configuration of infrastructure in the cloud. So this example is cloud. We can also do the same for on-premise infrastructure. The good thing with this, which you have probably already noted, is that because it's code, we can follow the same development principles that we follow for our normal development code. So we can version control it, we can unit test it, we can static analyze it, we can do lots of things with our infrastructure as code. And the important thing is it gives us a right snapshot of when something has changed, which is again benefits of Git or version control system that we use. So overall, this is what infrastructure as code is. These are a few examples of infrastructure as code. You may have already used something like Terraform, CloudFormation if you're using AWS, or Pulumi, which is multi-cloud similar to Terraform. Or you may have used ARM templates or Azure bicep, or even Farmer, which is the F# based Azure resource deployment technology or tool. So these are a few of the examples of our IaC. From my experience, I have about a few years, maybe 2 years roughly, experience with Terraform. I roughly understand how it works, how the state file works, how we deploy, plan, and destroy resources as and when we need it. Azure CLI and Azure PowerShell, those are super useful. I work mostly with Azure, so all my work with IaC is also around Microsoft Azure Cloud. So I've used lots of, I am still using Azure CLI and Azure PowerShell, as well as recently I started using Azure bicep. So from my experience, I have listed a few features I think we should focus on for the best features or the good features of an IaC language. The first is clarity, simplicity, and unity. It's really important that the language that we use, well, programming language or normal English language we're speaking, or even the IaC language, which could be Terraform's HCL, the HashiCorp language, or Pulumi using C# TypeScript, or even Azure Bicep. It has to be simple, it should be easy to understand, and easy to comprehend, mainly for users like developers, you, me, or infrastructure maintainers, or IT experts. Orthogonality. Orthogonality is the feature where changing A does not change B. So I read somewhere online that a very good example of orthogonality is when, say, you change the volume of your radio, it does not change the channel. So that is orthogonal. But at the same time, if you're in a helicopter, if you speed up, so that's increasing the speed of the helicopter, it's likely to affect the direction. So you need to controlling two things at the same time. So that's an unintended result. So you're trying to change A, but you are seeing a change in B. So orthogonality is important, that in infrastructure as code language, when you're changing something, it does not affect something else. Testability, which is it's quite easy to understand. the code we write should be easy to unit test or test. This is where I think Terraform does a good job, because we can unit test using TerraTest. We can also do static analysis and security testing using SNCC or TFSec. Modularity, it's again quite easy to understand. We should be able to modularize our code. We do not have to rewrite the same code again and again, rather create modules and reuse that. Registry, so there are two types of registry, private and public. Registry is when we can, the modules that we created in modularity, we can share those modules internally in our organization, say in a private registry, or throughout in public over the internet using public registry. Custom functions is when we want to write our own functions to capture or to reuse some specific behavior in our IaC. Declarative is when we, in our language, we say what we want to achieve, not how. Say, for example, we want to say we want to find a function app in a resource group. We just give the name of that. We don't say go and find, or we don't like the for. We don't have to write the for loop to locate certain resource group and certain function app. Imperative is sort of opposite to declarative. Here you have to say the for loop and try to explain how to achieve something, not necessarily what to achieve. The other features to focus on are IT support. How good is IT support? Does say the language, the IaC language, is it supported by Visual Studio, JetBrains Rider, or VS Code, or any other IDE in general? But it has to have good or bad. We should find out IDE support. Debugger support. Are we able to debug and find out issues in our IaC code? That's also quite important. Documentation. It's the thing with IaC, it's not only understanding what your cloud infrastructure or your local infrastructure, the configuration that you're trying to achieve, you have to understand that, as well as how do you do that using the IaC language. That's where the documentation comes into place. Terraform and Pulumi, both of them have very good documentation. Recently, Azure Bicep, Microsoft's documentation, and Microsoft Learn is providing very good documentation around it. Technical support, it's really important to have some support if you get stuck. So obviously open source GitHub, Terraform GitHub has issues you can open and interact with the development team of Terraform. You can do the same with Azure Bicep, and I'm guessing Pulumi also has very good support in place. And open source, is it really important for IaC to be open source? Most probably yes, because that gives us the ability to see what's going on and how certain, say, resources are being created and destroyed, and how the configurations are being set. State files. So both Terraform and Pulumi use state files to map their modules to the resources on the public cloud, Azure or Google Cloud or AWS, for example. I do not know if CloudFormation does that, but I'm guessing it will probably do it. But state files, is it important or not? Let's find out. Multi-cloud support. How important is for an IaC to support multiple clouds? So for example, Terraform and Pulumi, they support Azure, AWS, GCP, and a few other clouds as well. But at the same time, Azure Bicep, for example, and Farmer, they support Azure only, similar to ARM templates. So let's find out how important multi-cloud support is as well. One of the final points that I have is cost. Overall, it's a very good idea to have a very good language, but can we use it? Is the cost important? Is it too expensive, or is it free because it's open source? So depending on that, we should find out which ones are features of an ideal IaC language. So I did a survey, and I can quickly show you the response of the survey. And let's quickly go into my browser. And there you go. So you can say we didn't get lots of responses, but I can assure you the people who responded are quite well established in the software industry. So I'm happy to share what I've got. The quantity may not be high, but the quality is good. But because the responses are so less, we will try to compare with my opinion as well. I would say first of all, thank you to all who have responded. I know few of you, and it's very kind of you that you did take time to respond to this survey. Um, and I would sometimes I might politely disagree with what we have got here, but overall I do respect the fact that you did spend some time trying to respond to the survey. So thank you for that. So going through the features, first is clarity, simplicity. We can see that about 75% of the responders have said yes. That is, it's very important. So you can see up here that the colors show very important, important, nice to have, not necessary, or definitely no. So obviously clarity, simplicity, unity, we all agree. Either it's very important or important. I think it's very important. So thank you for that. Orthogonality, somebody has said not necessary, but most of them have said, well, three-fourths have said very important. And I agree with those three-fourths because we never want something to change unintentionally. Testability, it's been said very important, important, and nice to have. I think it is important. Is it very important? Well, to be honest, I think I'll say it's very important, mainly because the way we test our code or what we have learned over the years with software development, the testing is very, very important. We do not want to deploy resources to our cloud or say our enterprise software without the confidence of testing. Modularity, it's very important. Well, I agree as well. It is very important mainly because we do not need to rewrite the same thing again and again. We might as well make one configurable module and share it across our organization or over public. Private registry, it's very important. Majority have said not necessary. I would politely disagree here. I think private registry is very important because when we are deploying at scale, like the environment I work in currently is a company where we have 30 odd development teams, and I work in the platform engineering team, and we design these modules which are shared across those many, if not all, but majority of the teams. So to share that without having to pass on the burden of learning a language or IaC language in this case, sorry, it's really important to have the private registry in place. Public registry, it's important. I think it is quite important. Against the same idea that we should be able to share without rewriting the same code again and again. Custom functions, very important. I agree with that. And it's again not having to rewrite the same code again and again. Declarative, important. I would say it's very important. So I again politely disagree with most of the responders here because I think it's really important for the IaC language to be able to do something without us telling it how to. So we should be able to say deploy me this or with this. So that declarative way of saying get me this or deploy me that, that's quite important. Imperative, somebody has said very important. I would say maybe. I think it's not necessary in the sense that we should be able to just say I want something instead of how I want something. IT support is important, 75%. I would say I agree with you 100%. The IT support makes our life as developers or code writers or maintainers of IaC much easier. So yeah, 100%. It is quite important. Debugger support, 50-50 on this. I'm also 50-50. Maybe in the long run, yes. But do we need it immediately? I'm not sure. But yeah, once we list the final IaC values or the features, we shall find out. Documentation, very important, importance, almost 100%. It's important. And I'm with you as well, the responders. It is very, very important. Technical support, very important, important, nice to have. I think it is important, and technical support, to be honest, at the scale I'm working where we have roughly 8,000 odd resources running at any point in time, that's at that scale things can go wrong. So we do need the technical support. And for that reason, I think the technical support is very important. Open source, although 28% have said nice to have, 70% have said it is very important, and I agree with those 70%. It is super useful when the code is open source, and when we find an issue and we can't figure it out, we could look at the code and try to understand what it is that this IaC is trying to do. For that reason, I think I like Terraform's Azure RM provider, as well as I like bicep, because we can easily point out what is going on under the hood. State files, I'm glad that most of them have been nice to have to not necessary to definitely no. I would be in the not necessary category. My vote will go there. State files are good in some way because I can understand that they avoid or stop configuration drift. State files help us with optimization, like when you're deploying, the number of REST API calls that you need to do to, say, Azure REST API, for example, the management API, are much less when we have a state file, because every request doesn't go to Azure because you have a state file to say what you should be having. But at the same time, it can make our life very difficult, especially when we're working at scale. So if you think about, again, 5 to 8,000 odd resources being deployed using Terraform, and we have state files, and we have designed modules around it. If we rename a module, that module is effectively being removed from the state file. And if there is a resource mapped to that module, that resource, the Terraform will want to destroy that resource. So those kind of issues, and maybe that's why companies like HashiCorp as well as Pulumi have the enterprise version of their product, where they help deployments at scale to not have these issues. So that would make sense. But do we need state files? I think it's not necessary. Ideally, we should think about solutions without state files. Multi-cloud support. We have got one very important, but most of them have said not necessarily nice to have. I would vote for nice to have, mainly because the idea of using multiple clouds, it may not be very useful for a company unless you are like in constant fear of a cloud lock-in. But even if that's the case, it's almost always nice that you are able to use a cloud to its maximum value. Make sure you understand everything around it. You use like the best features around it, because that's how you can benefit more from a cloud. So for that reason, I do not think multi-cloud support is highly important, because even if it is, let's say we are an Azure house and we're using Azure Bicep, and because it doesn't support multi-cloud, so we will have to say, if we do move to AWS or we start using some AWS services, we'll have to write something else. That will in some sense make more sense, mainly because we're using the right tool for the right job. Azure Bicep for Azure, and maybe CloudFormation for AWS. So that's just my opinion. So that's all the responses I wanted to go through. And if we go back to our slides, what are the ideal features in my opinion? So in my opinion, clarity, simplicity, unity, like we discussed, this is paramount. This is the most important feature of the IaC language. Orthogonality, we do not want B to change when we do not want B to change. We wanted to change A. So the example being, when you change A, B doesn't change, or there's no unintentional change. So for that reason, orthogonality is very important. Testability, we discussed this. We should be able to test our IaC code, and we should be able to modularize it and share in private registry when we are working at scale, as we discussed. Custom functions will make our life easier in the long run, and being declarative means we just say what's the feature, what's the resource, what's the configuration we want, not how. ID support, this is where it's really important. I recently have been working Terraform and Azure Bicep in VS Code. The ID support is really good, it's brilliant, it's got snippets, IntelliSense, and highlighting, error highlighting and things. So it's really useful to have that kind of support in IDE. Documentation and technical support, these are both from the IaC providers. It's really important to have the right documentation and technical support. Finally, the cost. So this is where I really like Azure Bicep as well as Terraform, because as it's open source, and Azure Bicep, even though it's open source, free, and still is supported by Microsoft's support plan. So it becomes really appealing to anyone who just is using Azure. So I think, in my opinion, these are the ideal features of an IaC. It's cost effective, it's got good technical documentation and support, it's modularized, you can modularize, it has registry support, it is testable, orthogonal, and simple. And that's all my conclusion. So at present, I'm working out which is the best IaC though. I don't really have an opinion on that yet. I like many of them. Like I said, I like Terraform, I like Pulumi, I like Azure Bicep. Um, but again, right tool for the right job. I hope this was informative and thank you for watching. If you have any comments, suggestions, please tweet at me or follow me on Twitter. And this is the link to my blog post. So have a look if you like. Thank you very much, and Merry Christmas and a Happy New Year to you all.